Hello, welcome back to Floppies Rocks. Today I'm going to mod my Commodore 2040 disk drive. I'm going to make three mods to this disk drive. The first one, I'm going to make the device ID selectable. Now, unlike the later disk drives, this disk drive actually has three device ID select jumpers, so you can select up to 8 device IDs, all the way from 8 through to 15 inclusive. The later disk drives only had 2 jumpers, so you could select 8 through 11 device IDs. The second and third mods I'm going to make are both related. I want a reset button for this disk drive because there's no way to programmatically reset the disk drive if it gets into a bad state from your pet computer. But I'm going to add 2 reset buttons. One is to just reset this disk drive. The other is to reset all devices on the IEEE 488 bus. So I can select all the disk drives attached to the pet, or I can just reset this one. Now, I want to keep the front of this disk drive in as pristine condition as possible. I think it's in really nice state already, and I don't want to go messing around the front of it. So I'm going to do all of my mods to the rear of the disk drive. Let's take a look at the rear of the disk drive and see how I'm going to mod it. So the main logic circuit board sits here against the lid of the case, and you can see the IEEE 488 connector coming out here. So the circuit board itself is actually upside down, sits right up against the case, and then this bit hangs down. So I've got free space all the way along here to mount switches. There's also a fair amount of free space down in this area of the disk drive. We have the main incoming transformer and power supply capacitors here, but this area is actually free, so I could add switches fairly easily down here or all the way along here. Now there's also a hinge where these screws are going into, about the width of my finger, so that area is out. I don't want to be drilling into this vent here, so that puts that area out. So really, I've either got this area here just below the IEEE 488 connector, I've got next to it, or I've got down in the black portion of the disk drive case. Now thinking about how I'm going to use these switches, I'm going to be leaning over from the front towards the back, so I actually want them as high up as possible. I don't want to be leaning all the way down to the bottom of the case here, so I want them in this white area of the case. Now I don't want to have them next to the IEEE 488 connector, because when a cable is plugged in, it's going to foul that particular area of the case. So really that just gives me down here below the IEEE 488 connector. And it is going to be a bit of a faff with the cable connected, reaching over and accessing the switches, but they're either going to need to go here directly underneath it, or here next to the cable. Now the switches I'm going to use are these single throw switch for the device ID jumper selection, and then these momentary switches to act as reset switches. I've got a red one for the bus reset, I've also got black ones for the individual device reset. Now I'm going to want the buttons roughly centered between here and the top of the hinge, which is at this location. I'm just going to give myself a small pencil mark where I think the center of the switches should be, and it's probably about where that shadow comes to from the IEEE 488 connector. So I think the center of all of the switches and buttons is going to end up in about this location. So I'll be drilling on this line here. Now the widest diameter of the nuts and momentary switches is about 11 millimeters. So I'm going to need to make sure that at least these buttons are spaced at least on 11 millimeter centers. I'll probably go with 12.5 millimeter, so roughly ½ inch centers. And the washers for these single throw switches are also about 10.5, 11 millimeters in diameter. So again, I'll keep these 12.5 millimeters, ½ inch apart. So I need 3 of these switches, I need 2 of these buttons, so that's 4 gaps between them. 4 times 12.5 is 50, or roughly 2 inches. Let's mark where the centers are going to go. So for aesthetic reasons, I'm going to have them roughly in line with this IEEE 488 connector. think that's about right. So I'm going to want 5, 0, 2.5, and 12.5. If I can get it on 12.5, and 37.5. My eyes aren't really good enough to be able to get them to the 0.5 millimeter point, but that looks pretty good to me. So you've probably noticed that I'm drilling into this with everything still in place. That's because this area behind this part of the case is actually empty. The filter capacitors are here, transformers here, the circuit board's up here. So this is actually a free space in the disk drive, so it's fairly safe drilling into here. Right, I've got each of the holes started so I can move up size on my drill bit. So I'm aiming for around 7mm for the momentary switches and around 6mm for the device ID selection switches. There we go, that should fit the device ID switch. Yep. That should do it. And then I need to go one step higher for the momentary switches. That doesn't quite fit in that hole. Yep. So, holes made. Just need to clean those up a bit. So I now have the buttons and switches installed, and I think they look pretty good here. So this is the bus reset button, the red, the nuclear option, the device reset, black, and then the 3 switches for the device ID. I'm going to have them facing down for zeros and up for ones, and I think I'm going to have the one on this side, so the right hand side as I'm facing the front of the disk drive, and when I lean over the back being the least significant bit, and the most significant bit being on the left hand side, again from the front as I'm reaching over. Now we need to figure out how to actually wire these buttons and switches in. I've got the schematic here for the 2040, 3040, 4040 disk drives, and we'll take a look at the device ID selection to begin with. That's all provided by this riot chip here, UE1. Ports PB0, PB1 and PB2 we can see are connected through to ground here, and this particular point on the schematic signifies where you can actually cut the traces to allow these to float, or presumably they're pulled up by weak internal pull-ups high. The default position is them connected to ground, so all of these 3 bits are 0. The firmware upon boot reads the status of these address lines and simply ORs the value with 8 to get the device ID from 8 through to 15. The default setting with all these 3 pulled to ground means that they all read as 0, so 8 ORed with 0 is just 8, which is the stock device ID. So I'm going to need to cut the traces on the circuit board in this location here, and then wire my switches in either side like this. And how about reset handling? Well, the main reset circuit is here on the schematic, and that connects through to the reset line on the 6502 and also the riot chips here and here. It also goes to a different page on the schematic to reset some other chips. So we zoom into this part of the schematic, and remember we've got CPU off in this direction and we've got the riot chips up here. We have the IFC line coming in. This is the IEEE 488 connector, and IFC is essentially the IEEE 488 reset line. That comes in and then it goes through a voltage divider which has the effect of keeping this line at around 3.3 volts, and it goes through a couple of inverters here, a 7414 and then a 7406. Now IFC and reset on the IEEE 488 bus is active low, so when that line is pulled low, it resets the devices that are attached. So because it's going through a double inverter here, when reset is being triggered, we also get low coming up here and going into the LLM 555 via this route. So there's a couple of things I'm going to need to do to wire in both of my different reset switches. The first thing I'm going to do is to allow the black reset switch here to just reset this particular disk drive. I'm going to tap in at this point and connect my push button to the line there and also connect it through to ground. That will ensure, because it's on this side of the double inverter, it will prevent that signal from getting transmitted back onto the bus. And then, fairly obviously, I'm going to install my other push button at this location on the drive to allow the actual ISC line from the IEEE 488 bus to get pulled to low, to pull all devices on the bus to low. Now when I say all devices, I mean all devices are not IEEE 488 controllers. So the PET generally acts as an IEEE 488 controller, and the circuitry inside the PET does not allow it to be reset via the IFC line on the IEEE 488 bus. So yes, it will reset all the disk drives that are attached and any other IEEE devices, but will not reset any controller that's attached. We'll take a look at the drive now and see where we've actually got to solder things into. And we'll start off with the device ID selection connections. So the pads for each of the device ID jumpers are these small double semicircular shapes here, and I think the intent is if you want to change the device ID, you actually cut in the middle of this. That's incredibly fine, it's definitely sub-millimeter gap, so actually I might just cut on the other side of these pads. So this is the ground line, so I just need to make sure I cut on this side and then solder each of these three switches into the appropriate pins here. I think this pin 24 here is the least significant bit, yeah, and then so 23 and 22. So I need to connect each of these switches into one of these pads down here once I've cut those traces. We think about the reset line. Well, the IEEE 488 IFC reset signal actually comes all the way over to UA4 here. So for the bus reset, I need to either connect into pin, looks like it's pin 3, or the schematic's quite hard to read here, or the voltage divider, which I think is R4 and R6. Again, it's quite hard to read. I'll need to tone it out with a multimeter, but it'll be easier to solder to the appropriate leg of one of these resistors. So that's likely what I will do. And I think it will be this point here I'll end up soldering into, or potentially this of R6, we'll see. Then the reset line makes its way all over to here, and this is the 555 timer that actually drives the reset circuit for the 6502 and the Riot chips. So for the reset button for just this disk drive, I need to be soldering in somewhere over here, and I need to be pulling pin 2 of the 555 low when the button is pressed. Now rather than soldering directly to the 555, I'll probably solder to the appropriate leg of R8. R8 and C19 are connected together, and this point should connect through to pin 2, so that's an easier place for me to solder into. Soldering done. I've tapped into the main IEEE 488 IFC line here and the drive zone reset line here. I've got cables coming out of each of the three jumper locations for the device ID, and I've got a ground wire connected here, and I've got the same ground shared with all of my different buttons and switches here. So at the bottom here of these switches I've got a ground cable comes to here, and then those can connect together. Here I've got the bus reset line, here I've got the drive reset line, and here I've got the device ID switches. So I'm just going to give everything a quick test to make sure it's working as I would expect. So I've got the fluke. I shall put it onto continuity mode, and get some glasses. So we shall check. So we've got this device ID switch set to on at the moment. It's actually in the up position, but it's upside down. So this is equivalent to the down position. This should be the most significant bit. And if I switch it off, it's no longer connected. This one should be connected. Switch it off, it's no longer connected. And this final one should be connected. And if I switch it off, it's no longer connected. Alright, so I'll leave those back in the device 8 position. And then test my momentary switches. It'll be a bit more fiddly for me to do this. So no continuity. When I press it, got continuity. So that's the drive reset. And then the bus reset, no continuity. Push the button. I have a reset signal. Excellent. And then I shall also check that I have soldered into the right points on the motherboard. So pin 3 of this 7414 should be connected to here. It is. And then pin 22 should be connected to the grey one. Pin 23 to the purple. And pin 24, least significant bit, to the blue, which is going to connect over to here. And then finally, the LM555 should be connected to here, which it is. Excellent. So I think I've certainly wired it up as I intended. Hopefully that's correct. So now I'll just connect together all of the cables. Just like that, it's all connected. Hopefully obvious, but I've gone with DuPont cables so I can easily disconnect the motherboard from the switches and buttons and remove it from the case for troubleshooting, diagnosis in future. And I'll tidy the cables up a little bit with some cable ties, strap everything together once I've verified that everything is actually working as I expect it to. We should do that now. Moment of truth time. I have it all back together and I've got it plugged in. So let's turn it on and check that it actually boots. It does not. Now let's try that again with the power switch in the other position. There we go. It's successfully booted. I've got all of the 3 switches on the back in the down position. So let's see if it's detected as device 8. It's detected as device 8. Now what I'm going to do is I'm going to change the least significant bit. So this should make it device 9. And then I'm going to use the device reset button to reset the disk drive. So we see the reset lights come on and then they go out. Then I detect again and I see device 9. Excellent. Let's try device 10. That should be device 10. Let's reset it. And detect device 10. Let's try device 11. Device 14. And finally device 15. Yes, excellent. Just one more thing to try, and that's whether the bus reset actually resets the entire bus. I need another device to do that. But let's just check that this still resets when I use the bus reset. It does. I've hooked up my 2031. So both the 2031 and the 2040 are now sharing the IEEE 488 bus. This is still device 15. I'm not sure what device the 2031 is set to. It'll either be device 8 or device 9, but let's find out by trying to detect it. Right, excellent. So we see device 9 and device 15. Let's just reset the 2040 and check that the 2031 does not reset. Okay, that was just a single device reset. So we saw the lights come on this drive, but not this drive. And now do a bus reset. So this drive span and the red light came on, indicating that it reset. So that functionality is working. And then finally, I will reset this 2040 back to device 8, do a device reset, and we'll check that's taken effect. Right, device reset time. That one reset. And we have device 8 and device 9. Excellent! Successful mod. This was one of those rare occasions where everything goes according to plan. So given the nightmares I've had in recent videos, I'm quite pleased to have an easy one. This 2040 is going to come in very useful to run alongside my other IEEE 488 disk drives, not just because I can select from the full range of 8 device IDs, but also because I can reset it and also the bus independently. I hope you found this video interesting and useful. If you did, please do consider sticking around. Till next time, rock on.